Hello everyone. In the previous video, we have studied about the Rutherford's model of atom, alpha ray scattering experiment, etc. Now, let's discuss drawbacks of Rutherford nuclear model of atom. According to the Rutherford, when electrons revolve around the nucleus in a circular path, like this. But this electron is a electrically charged particle. When this electron revolve around the nucleus, so according to the Maxwell theory, when a charged particle revolves in a circular path, it accelerates. Its direction changes due to electrical and magnetic field. And when the direction changes, it comes near to the nucleus and finally falls into the nucleus. In this way, an atom cannot exist. So, further, this theory is explained by Niels Bohr. So, there are drawbacks of Rutherford model. First is this model failed to explain the stability of an atom. This model fails to explain the stability of an atom. And when Niels Bohr explained the different spectral lines present in the hydrogen spectrum, so after that this model is also unable to explain the existence of a spectral line in the hydrogen. This model fails to explain the different spectral lines in the hydrogen. So these are the drawbacks of Rutherford nuclear model of atom. Now, first we will discuss about the discovery of neutron and then about the Bose model. So, next is discovery of neutron. Neutron is discovered by James Chadwick in the year of 1932. In 1932, James Chadwick discovered neutron. Neutron, a neutral particle present in the atom. When he bombarded beryllium with alpha particle means helium nuclei. When he bombarded beryllium metal with alpha particle, carbon 12 is formed along with a neutral particle called, this particle is called neutron. James Chadwick did various experiments regarding this, but this is the most successful experiment did by him in 1932, that he bombarded helium. Helium means this is alpha particle on the beryllium metal and form carbon, and the neutral particle neutron is discovered. The properties of neutrons are, as you know, its mass of neutron is equal to 1.67 into 10 to the power of minus 27 kg or 1.67 into 10 to the power of minus 24 gram. There is no charge. Charge of this particle is no charge, 0. So, mass of the atom depends on the proton and neutron present in the atom. So, let's discuss the atomic number first, then mass number. What is atomic number? You all know atomic number very well. What is atomic number? Atomic number is number of proton present in an atom. Atomic number, which is denoted by Z, is nothing that number of proton present in the atom. Proton present in the, where it is present in the nucleus of an atom. Henry Moseley. This atomic number, as we can say, that is proposed by Henry Moseley in the year of 1913. Scientist Henry Moseley, you all well know Moseley, as Moseley is the Moseley forms the modern periodic table. He calculated charge to the nucleus from frequency or wavelength. He calculated the charge by X-ray emission by different element. He showed that when metal plate, when cathode ray is stuck to the metal plate, different spectral lines are formed. By analyzing, by observing that lines, he observed that spectral line is due to the number of protons present in the atom, and a plot of wave number is done against the atomic number, then a straight line is formed. On the basis of this plot, Moseley proposed that the atomic number of an atom is the number of protons present in the nucleus of the atom. Next is mass number. You know very well mass number. What is mass number? Mass number is number of proton plus number of neutron present in the nucleus of an atom. As the mass of the hydrogen is very small as compared to the mass of the proton and neutron, so it is considered as negligible. So mass number is the number of proton and neutron present in an atom. We can also write mass number as A, and proton can be written as Z. So to calculate the number of neutron or the mass number, we can use this formula. Next term is isotopes, isobars, etc. So let's start with isotopes. What are isotopes? We know very well from the study of class 9th and 10th. We know very well that what are isotopes. Isotopes, we can say that atoms having same molecular formula. You all know it very well. Atoms having same atomic number but different mass number are called isotopes. What are their properties? Their chemical properties are same, but the physical properties are not same. Or we can say that they have same chemical properties but different physical properties. Start from the isotope of hydrogen. There are 3 types of hydrogen isotope: hydrogen, protium, deuterium, and tritium. An element can be written as X. Here, mass number is written here and atomic number is written here. So, these are the 3 isotopes of hydrogen called protium, deuterium, and tritium. Carbon 12, carbon 13, and carbon 14. Carbon 12 and carbon 14 are naturally occurring. As you all know these isotopes. And there are various isotopes. Almost each and every element in the periodic table has isotopes. So these are the isotopes. The main thing in this isotopes are, what about the number of electron, proton and neutron of the isotopes. The number of electrons, as the number of proton is also equal to the number of electrons in a neutral atom. So number of electron, if we consider carbon, it is 6 and 6. And what about nitrogen? Neutron. What about neutron? Here the number of neutron is 6, number of neutron is 7, and number of neutron is 8. Here. So isotopes are those substances which have same number of protons but different number of neutrons. What is different here? Neutrons are different. Neutrons are different neutrons are present in the isotopes. There are various uses of isotopes, as you all know it very well, that there are various uses of isotopes. Next is isobars. What is the difference between them? Isotopes and isobars: atoms having same mass number is same mass number but different atomic number. They have different chemical and physical properties. The examples of these isobars are like C14 and N14. This is 7 and this is 6. What is same here? There is same mass number. Mass number are same. What about electron, proton and neutron? They have 6, 7. 6, 7. But what about neutron? They have 6 and 7. 6 minus 14, 8. And this is 7. So, they have different number of protons and neutrons. What are different? Different protons and neutrons. Nothing is same, but only mass number is same. Same mass number and different atomic number. Next term is isotones. What are isotones? Nothing is same, but only the number of neutrons are same. Atoms having same number of neutrons. Only neutrons are same. Like, if we consider the period number 1 of the periodic table, there are some examples of isotones are like 1 or 2. Consider sodium and magnesium. Sodium atomic number 11, magnesium atomic number 12. Sodium mass number 23 and Here mass number 24. Electron, proton and neutron. Electrons are 11, 12, protons are 11, 12, and what about neutrons? Neutrons means 23 minus 11, here 24 minus 12. As we know that number of neutrons can be calculated at A minus Z. So here number of neutron is 12 and number of neutrons is 12. So they have same number of neutrons. So they are considered as isotones. They are different. They have different physical and chemical properties. If we summarize the properties of isotopes, isobars and isotones, then isotopes have same. If we consider proton and neutron, if protons are same, electrons are also same. If we consider proton and neutron, they have same number of protons but different number of neutrons. In isobars, they have different number of protons and different number of neutrons, and in isotones they have different number of protons but same number of neutrons. So these are some isotopes, isobars and isotones given here. Now let us consider some questions. Calculate the number of electron, proton and neutron in the following. This is the question. Calculate number of electron, proton and neutron. Electron, proton and neutron in the following. In the following. In the following. Phosphorus 1531, phosphorus 3 minus 1531. Next is bromine 35, 80 and zinc 30, 64. Strontium 38, 90. Strontium 2 plus, and tellurium. Tellurium having atomic number 43 and mass number 90. Next question is, in which atomic species neutron is not present? In which atomic species neutron is not present? Next question is, the number of electron, proton or neutron in a monoatomic species. Neutron in a monoatomic species 26, 35 and 45 respectively. Assign the proper symbol. Write the proper symbol. Proper symbol means which atom is it? Answer these three questions in your notes and submit me. And next is we are discussing now about the nature of electromagnetic radiation. Before going to the Bose atomic model, let's discuss the nature of the electromagnetic radiation. As we know very well that cathode ray, anode ray, these rays are electromagnetic radiations. Then what are the properties of these electromagnetic radiations? So let's start with them. Nature of the electromagnetic radiation. We all know that electromagnetic radiation deviates in electrical and magnetic field. But how they behaves in electrical and magnetic field, and when both the electrical and magnetic field are applied, then what are the nature of the wave next? So to understand these, let's summarize the properties of electromagnetic radiation. Electromagnetic waves are associated with oscillating electrical and magnetic field. You can write that electromagnetic radiations are what are that? The electromagnetic radiations are oscillating. Moves in its own axis, oscillating electrical and magnetic, oscillating electrical field and magnetic field. These electrical magnetic fields are perpendicular to each other. Perpendicular to each other. Like X, Y, Z. If it is electrical, this wave is electrical waves. If it is electrical waves, then along the x-axis, then the waves along the y-axis are like this. This is magnetic y-axis. So the direction of the wave is along the z-axis. X-axis is electrical waves, y-axis is magnetic wave, and so the direction of the wave is along the z-axis, because these two are perpendicular to each other. So the direction will be on z-axis. If electrons revolve around the nucleus, if these electrons revolve around the nucleus, then by each and every time it changes its direction. So due to the change in direction, it spirally moves into the nucleus and falls. So this to consider this type of movement, we should understand the electrical and magnetic nature of the waves. And the second thing is different electromagnetic waves. Second thing is different elements shows different type of electromagnetic radiation. If we consider with gear, they have different frequencies, different wavelengths. So different electromagnetic radiations have different wavelengths. Different electromagnetic radiations have different wavelengths. Wavelengths are different, so frequencies are also different. Wavelengths. They have different wavelengths. And they do not need the medium. They do not require medium and can move in vacuum. So let's understand the different frequencies and wavelength of different type of radiations.